versus convex. What do you think? Give me a number, Suki, and tell me what you think it belongs, where it belongs. 4. 4 is convex. Okay, and why?
Because it is clear to see which points are on the inside and which are on the outside.
Yeah, so what the book does is really interesting. I've never seen a book do this before. They talk about what's easy to tell as an interior angle versus what's difficult. And that's okay. How do you guys feel about that? Does that help you?
No.
It didn't help me too much, but it might help some people. So the book talks about easily distinguished interior angles versus exterior angles. So with that idea, I've got another way to do it. With that idea, give me another one, Kat.
One is concave.
One is concave. Okay. So AJ.
6.
Right. Sammy's.
3 is convex.
3 is convex. Nick.
5 is convex.
And then Quinn.
2 is also convex.
2 is also convex. Okay. So the book talks about these interior angles and exterior angles. It is important to know what they are. So interior angles, you know, it sounds kind of silly that the angle's on the inside. So just something else I want to tell you about. In some books, they mark angles with like little tick marks. Your book doesn't do that. Like they might put 2 marks there and 1 mark there because they're not the same. And today, in these pictures here, if a book wanted you to know that all the angles are the same, they might mark them all with the same little tick mark. So these are all examples of the interior angles of this decagon. And since figure 1 on the left here is a star, we just look at it bigger here. The interior angles, they're all of these, and they're different. So some books will mark them, the ones that are the same in the same way, with tick marks or maybe the same amount of little arc marks. These are all the same. And these are all the same as one another. Altogether, there's still 10 angles. It's a decagon. It's just a concave decagon. Okay? Does that make sense? They're just throwing out the marking. Now, that's not to be confused with when your book does an angle like this and they use an arrow. They're just showing you what angle they're talking about. Okay? But that blue angle is an exterior, is outside of the polygon, but it's not really considered. So it's outside of the polygon, but it's not really what the book defines as an exterior angle. And we're going to come back to that, but that was one of the other terms. They do talk about the types of angles and say on this set of shapes, it's easy to see what is an interior angle, I think is how they talk about that. Hang on, Quinn. So here's what most geometry books do, and I want you to think about if this makes it easier. I find it makes it easier, but you know, everybody's different. But in most books, what's the color we can see there that's not
Purple.
black?
Blue.
Maybe the blue. Most books talk about diagonals when they talk about concave versus convex, and we've already talked about diagonals, so it's a good way to think about this. A diagonal, it connects any 2 vertices that are not already connected by a side. Right? So all these blue dotted lines are diagonals. Okay, there's 5 diagonals in that pentagon. And these are the diagonals here. And in this shape, there's 6 diagonals. There's more. There's another one. So I'm connecting vertice to vertice, but not the ones that are already connected by sides, and am I missing one? I got them all. Okay? Do you see those blue dotted lines are all entirely inside the shape? Okay. When you can find a diagonal that is not into the shape, we would call it a concave polygon. So if you can find one diagonal, just one, that's outside of the shape, like this one, then that would make the shape concave versus convex. And I think that's an easier way for people to visualize what concave means compared to what your book does.
Yeah.
Like your book just makes it a little complicated, I think. It's just my opinion. Like 6 has this diagonal too, but because it's a quadrilateral, it still has 2 diagonals. It's just that one of the diagonals is outside. And if there's at least one diagonal outside, then you would say that it is concave and it is not convex. Quinn.
I thought it was going to be like, if there was if the shape seems like it points outward.
Okay.
Angle, but that meant it was going to be, an exterior angle. Like on number 3, the point at the bottom, I thought that would be considered an exterior angle. Because it points outward as compared to like on number 1.
I think that's why the book uses that description. Pointing outside versus pointing inside. And I think that they're trying to give you a visual. It's just been my experience. I think you understood what the book was saying, but I think for most people that's a little confusing. But I think you're right. I think that's what they're trying to get at. Yeah, you got. It always works. Well, let me give you one more thought. Another way to think of the word is when something caves in. Imagine like if the ceiling caves in, it's kind of falling forward. Don't these concave polygons look like you can sort of imagine this is caving in? You know, that's another way to think of it. I think, Quinn, as long as you can think of a way that works for you, you're getting it, and your definition always works, then I would stick with it. Because we're doing this in an informal way. When you get to geometry, you have to be a little more formal about it. But if you can look at those shapes and realize that 1 and 6 are the concave ones, then that works great. Okay? 3 doesn't have diagonals, right? So there can't be a diagonal outside the shape. So it even works for triangles. Triangles don't have diagonals. Because when you take a vertex and connect it, it has to connect to an adjacent side, and the diagonals connect to non-adjacent sides.
Wait, so a triangle is always convex?
So a triangle always is convex. Exactly. Ben.
I know the way that Quinn could remember it.
Okay.
Convex has vex in it. It's vex is essentially a curse. It's cursed to never have an exterior diagonal.
Okay. So we're going to keep going. I hope that worked for you. Let's go to the next thing. So that's something that's one of your goals, is to be able to identify convex versus concave. One of the other things that came up was about what is an exterior angle. And an exterior angle doesn't really just mean an angle outside the polygon. It's way more specific. Did anybody notice what their picture was with the exterior angles?
Yes.
What did you notice, Sandy?
It's not like they're adding an extra line instead of a line that's already there.
I'm not sure what you mean. So in other words, is this angle right here, this angle, is that exterior? Does that count as an exterior angle? What do you think? Yeah. In the book, yeah. Yeah, it's more of an extension. So these exterior angles are drawn in the book. So we really look at exterior angles mostly on convex polygons. If you think of what I'm doing, I'm sort of just extending each line. Have you ever seen like I know like you do slideshows on your computer now, and they'll kind of do this little, look at these here, where these close up. Like it used to be on an old camera, even if you have an iPhone, you'll see a picture where it kind of looks like the polygon opens and closes. Well, that actually comes from kind of like old cameras. So I've extended all these lines on polygons, and I extend in one direction. Okay, and so when we look at exterior angles, we're only interested in the angles. These angles really related to convex polygons. So again, if I were just kind of showing you what I just did, I would start and go, basically I'm going counterclockwise. If there's a triangle, there's 3 sides, so there's only 3 exterior angles. If there's a pentagon, I'm going to work my way around the pentagon, and I see, by extending this, there's 5 exterior angles, and I'm going to number them. And like I said, on a triangle, there's this one, and this one. See that? There's a reason you want to look at these. It makes some of your math way quicker. So out here, this is 1, 2, 3, 4, 5. There's 6 exterior angles. Okay, Catherine.
So, if you like want to know how many exterior angles there are, could you just count the points on the sheet?
Yes. So exterior angles, that's an angle symbol. There's the same amount of exterior angles as there are vertices. Okay? Caleb. Caleb?
Measure an angle with an exterior.
Okay, so yeah, this page is probably a better page to look at. We're going to get there, but what do these shapes start to look more and more like? Like going from the triangle. Don't they start to have a circular appearance?
Yeah.
Like this is a 16-sided polygon, and it just looks like a circle, doesn't it? Almost, because the sides are so small. And I'm just curious, if I told you that this angle here was 110 degrees, and that this angle here was 30 degrees, what would this angle have to be? 40, right? Okay, so exterior angles always form supplementary pairs with the interior. So for example, angle 2 has a measure of 70 degrees. Do you see that? Because they form that straight line. Angle 3 has a measure of 120 degrees. And angle 1 has a measure of...
Why is it 120 to 150?
Oh, thank you. I had it wrong. I think that was, I don't know what I was thinking. 150. And this is 140. So, just, okay. So let me write a little, let's just look. You're trying to recognize what an exterior angle is, so you should be able to recognize an exterior angle. Sorry. Just what does it look like, okay? And then you should be able to use the exterior angles. This is the goal. To find the measure of the interior angles. Okay, so in order to do that, I'm just trying to get you to see what they look like here. So raise your hand if you understand how to see that you know where they are, what they look like. Be honest, you guys. So for example, over in this picture right here, the exterior angles are angle 1, 2, 3, 4, 5, and 6. They are outside the polygon, but they're formed by extending each side of the polygon. Okay, now raise your hand. Okay, so for example, if I look here, we don't really look at angles that are just outside the polygon. We're not interested in that. We're interested in the exterior angles that are around the convex polygons that are formed by extending the sides. You see the difference? And if I extend the sides here, now there's an exterior angle there. Okay? But if I extend this side, it doesn't really work so much. So we're going to look only at the convex polygons because it's going to help you do some math that makes things really quick. It's going to help you find interior angles in a quicker way than when you did yesterday. Okay? So the next thing I did was I said when you look at just this page, because we have a line, remember a straight angle makes 180 degrees. So these two angles together have to be adds 180. So does 70 plus 110 because they make straight lines. Getting it? Okay.
Oh, so
And so do 40 and 140 because they form a straight angle. There's a reason for this. You kind of have to go with me, but so I'm just seeing, do you see that supplementary relationship? Quick question, Ben. Is it quick?
Well, it's not a question, but I think I know how to find the interior angle from the exterior.
Hold on.
Why you have to get 180 inside of it and then 360?
Okay. So we're not done yet. The 360, I don't know where you got 360, but we're coming up to 360.
Yeah.
So did you read about that? So that's good. When you look at these three angles in red here, add them up. Isaiah maybe already has done that. When you add these up, you get 360 degrees. Do you see that? Do you remember I asked you, I said, don't these start to look more circular when I draw more sides?
yeah.
Well, let's look at this. This is a regular pentagon. Does anybody remember what one angle of a regular pentagon is? If it's regular?
108.
108. Okay? So the supplement, angle 2, would have to be 72 degrees. Because 72 plus 108 make 180. You see that? So each of these out here is 72 degrees. How many of them are there?
5,
5. What's 5 times 72?
360.
It is, because 5 times 70 is 350, right? 5 times 2 is 10. This is 360 degrees. Totally different shapes, but their exterior angles all add up to 360. Now look at this. Who remembers what the angle of one angle in a regular hexagon is? 100 and what? Nick? It's 120. So don't worry if you don't remember these. You can figure them out. So what is the supplement of 120? What's angle 1 going to be?
60.
60, right? And this is 120 right here. So this is 60. And this would be 60 and 60 and 60 because the polygon's regular, right? How many angles are there outside? How many exterior angles?
6.
What do they add up to?
360.
360. Catherine.
So for that also, could you like add up all the the points and then divide?
Exactly. So look at if you didn't know that, say you forgot the angle of the measure of one angle in a regular hexagon, but you know the property that the exterior angles always add up to 360. In a regular hexagon, they're all equal, right? So these would all be the same value. You see that? They're all the same size. And there's 6 of them. And those 6 angles add up to 360. So one of them would have to be 60 degrees. True? So that means the supplement, if this is 60, you would subtract from 180 and get 120. And I didn't use the number of triangles, like yesterday.
You still use the number of triangles?
You can't. But I would ask that you try this just a few times, because it might be that you like it better. So for example, does anybody remember what one angle of an octagon is?
70.
No. So if I just think about how many exterior angles are there, how many are there? And they're all equal, right? So I don't really need to keep drawing the picture. I'm drawing it just to get you guys used to thinking this way. Like, you wouldn't need to do this. What you need to know is all 8 of those angles add up to 360. So if I divide 360 by 8, 8 goes into 36 how many times? 4. What's the remainder? 32 from 36 is 4. How many times does 8 go into 40?
45.
So this angle out here is 45 degrees. What plus 45 makes 180? 135. You see what I'm doing that's a little different? It's a little shorter. For some people that like that shorter method, if I ask you to find the measure of one angle in a 16-sided polygon, you could use the exterior angle theorem to do that. You could take this picture and then you can do that without, put it over here. So it's 16 sides. I mean, really, we have 2 methods. So you have method A, what you used to do, what you still might want to do, and we'll go through that. And then the new method. So the new method says if there's 16 sides, there's also 16 exterior angles, and I know they add up to how much?
360.
No matter what, right? I'm going to divide by 16. Okay? So, I'm going to just do a quick calculation here.
20 with 1 meter.
Yeah, you guys, where'd my calculator go? Okay, well, I guess it's wanting us to work it out. So, divide by 4, so you get 90 over 4, right? So that's 45 over 22 and a half. So every single little angle out here is 22.5. So now you can find one angle by subtracting 22.5 from 180. So when I do that, you get 157.5 degrees. Okay? So before we go to the other way, you should be able to recognize what an exterior angle is. Raise your hand if you can. Okay, good. And you should be able to use that exterior angle and the property of 360 to find the interior angle. Okay? Let's look at the second method and then I'll take questions. So the old method would have been figure out how many triangles there are from one diagonal. So how many triangles can be formed from one diagonal? 14 triangles, right? Number of sides take away 2 times by 180. This gives you the total sum in a 16-sided figure, right? So what's 14 times 180?
This is killing me to do it.
2,520.
Good job. Okay, and I want to figure out one angle. What do I have to do?
Divide by 16.
Divide by 16, right? Sort of more work. When I divide it by 16, you're gonna get 157.5. You just get it differently.
It's a lot longer.
It's longer, but the drawback of it, this method might be that it's new, and there's one more thing to learn.
Need a picture of that.
You don't. Right. I kind of picture everything anyway. I don't always draw it out. Okay, so I'm going to just stop this for a minute. We can do some questions. So, Grant's question, the irregular polygons, it works all the time. So, if I make up an irregular polygon, so the way it can come into play, you can't, no matter what, like if I made, let's say this is 130 degrees, and this was, it looks kind of close to about 90, a little less, 85. I just sort of kind of make these up and say this is about 70. First of all, you should be able to find x. And they're not equal because it's not regular. So if I did 130 and 70, that's 200, plus another 85 is 285, and I subtract that from 360, I can find x. So that's last week, or early this week. So when I do that, what do I get? You guys agree? 75? Okay. So Grant's question is, will the exterior angles still add up to 360 if it's not regular? And we can answer that just by figuring out using supplementary pairs. What does this angle out here have to be? Outside, the exterior. 50, right? How about this angle out here? 95. Okay, how about this angle here? 110. How about this angle here?
105.
105. So 105 and 110 make 215, right? Plus 95. 310 plus 50. 360. Still works. And you're going to do some problem solving with that today. So I'm going to just stop it.